Alright, so our last section for this week is trig identities. We've already gone through the trig identities. We did them back in chapter 6. I just had you write them down. But I'll put them on the board again in case you need them. So just remember in general what an identity is. It's an equation that is always true. You could think of the Pythagorean theorem. That's kind of like an identity. Right? If you plug in a squared plus b squared, it always equals c squared. And if you say, well, what about if a was 2 and b was 4? Yep, it still works. What if a was 6 and b was 13? Yep, it still works. An identity is something that always is true. It doesn't matter what you plug in. So these are the 3 groups of identities we already have in the notes, but again, I'll put them on the board if you need to see them. The reciprocal ones we've been using right along. Like we don't have a button for cosecant, so if you take sine and flip it, you get cosecant. That's a reciprocal identity. The tangent and cotangent identities are kind of like this. If you take the sine divided by the cosine, you get the tangent. So we did a little bit with that. The last group we didn't do anything with. Okay, I gave them to you, but I said we're not going to use them until much later. Well, now is later. Later's now. Something like that. So anyway, we're going to do them today. So let me, oh actually I already have them. Perfect. So here's your 6 reciprocal. And the 3 on the top are really repeats of the 3 on the bottom. This one is saying if you flip the sign, you get the cosecant. Well, the one above it is saying if you flip the cosecant, you get the sine. Well, yeah, it's just changing it back and forth. Okay. If you flip the cosine, you get the secant. If you flip the secant, you get the cosine back. So there's really only 3 reciprocal identities. They're just writing them different ways. There's your quotient ones. Okay, I gave you the first one a minute ago as an example. So sine divided by cosine gives you tangent. And if you flip it, cosine divided by sine, that's the cotangent. And then the last group of identities, we've never, we wrote them, but we never did anything with them. So I'm putting them up again. Okay, sine squared plus cosine squared equals 1. The next one is 1 plus tangent squared equals secant squared. And the last one is 1 plus cotangent squared equals cosecant squared. Now, they used x's for all these. They didn't put any numbers in because these formulas are true no matter what numbers you put in. So I could say like the tangent of 12 equals the sine of 12 over the cosine of 12. The tangent of 52 equals the sine of 52 over the cosine of 52. It doesn't matter what number you plug in, it always works. And if we let's look at this one for a second. Sine squared plus cosine squared equals 1. Well, you might see something like this in a problem. That's the same thing. What I just wrote in black here and what's in that box right there, all you did was take something that was in the box and put it on the other side. If I subtract sine squared from the left and from the right, that's gone. And you get cosine squared by itself equals 1 minus sine squared. Cosine squared by itself equals 1 minus sine squared. So let me get rid of that. Okay, what I'm showing is you can take these identities and you can move like something to the other side. All right. Okay, does everyone have what's in that blue box? Those identities. All right, so let's try some problems. So we don't really get into the application, right? We're not going to do word problems with these and kind of take it to that point. We're just going to take a trig expression and simplify it. Where this would come up is in like a problem that would involve calculus. You might have a really complicated trig expression like that, and maybe you have to do something with it, but before you do anything with it, you want to simplify it as much as you can. It's kind of like reducing fractions. If you reduce the fraction before you do stuff with it, it makes it easier. That's what this is. We're trying to make it easier before we would have to do something with it. But the thing you would do is calculus, so we're going to stop once we make it simpler. That's all we do. Right, so let's look at go back here. So there's a few different tricks that we're going to use to simplify identities, and we're pretty much going to use these same 3 tricks every time. One trick is to take everything in the problem that is not already sine or cosine and make it sine or cosine. Now, that's a trick you can try. Is it always going to work every single time? No. That's kind of like if you told someone to play chess and you said, you know what, every time you play chess, you should always do this move. Well, maybe. It depends. Like, maybe it's a good move a lot of times, but sometimes, depending on the situation, it might not be a good move. Same idea here. But it is something that does tend to work a lot of the time. Okay, so let's try this one. So we've got cotangent divided by cosecant. And the directions are to simplify. You're going to see 2 main types of problems in this section. Simplify and verify. Simplify is harder because with simplify, they just give you some stuff and they say do as much as you can until you think you're done. When you get a verify problem, they give you a bunch of stuff and they already tell you what the answer is. So all you have to do is simplify what you have until you finally end up with what they said you should have. Right? So verify is kind of nice because you know what you should get. Simplify, we don't. I think you'll know when we're done though, because it's going to be as simple as you can go, and you'll see you can't go any further. You'll kind of know. So let's start with cotangent. How can we rewrite cotangent? So it's just sines and cosines. Yep, Michael?
Cosine divided by sine.
Yep, it's cosine divided by sine. And what about cosecant? That's 1 over sine. Now, once we get it to this step, we treat that exactly like it was an arithmetic problem. If you had something like this, how would you divide fraction by a fraction? What do you do?
Multiply by the reciprocal.
Right, you keep the top exactly the same. So that's what I did. We just copied down the top, cosine over sine. And now multiply by the reciprocal of what's in the bottom. So Kat, what's the reciprocal of 1 divided by sine?
Just sine over 1.
Just sine, yeah, just sine over 1 or just sine. Now when I multiply straight across, what ends up canceling out? Sine. You can always cancel if you have something in the top and the bottom of a fraction and it's multiplication. If it was addition, you can't do that. When you have addition between fractions, you can't cancel. Or subtraction. Multiplication, you can. And all you end up with is cosine in the top. It's just divide by 1 in the bottom, so you don't even need it. And you're done. So we took a problem that had 2 trig functions with division. And now that we finished it, it's just a single trig function all by itself. Any questions on that? That's the idea of what we're doing today. They get a little harder, but if you can do that, you're a good start. This is about the same difficulty as the last one. Cosecant times tangent. Right? So keep that trick in mind, change everything to sines and cosines. Even if you're not sure what's going to happen, just do it. And then something will probably happen that's helpful. Most of the time with identities, that's kind of how it works. Just try something. You might not even know what's going to end up happening, but you just hope something good happens. Right. So Rebecca, if I start with cosecant, how can I rewrite that one?
1 over sine.
Yep. So 1 over sine times. And Connor, what if I rewrite tangent?
We need to do this tangent. Oh, we're trying to sine over cosine.
Sine over cosine. I've got multiplication between the two fractions. Does that mean I can cancel, or no, I can't? I can cancel. What can I cancel out? Sine. So Michael, what does that leave me with at this point?
1 over cosine.
Leaves me with 1 over cosine. Now you could argue, am I done there? I would say if you could write this so it's not a fraction, then that's simpler than a fraction. So what is 1 over cosine the same as? Secant. And now I would say you're done. You've got a single trig function all by itself with no arithmetic. There's nothing else you can do with that. Secant. Okay, questions on that one? Great. So I already kind of mentioned this to you, and we're not going to do this for the next problem, but I think the one after it is a verify. Yeah. So verify, you're being given a left and a right-hand side, and they just want you to show how one side is the same as the other. So you know what the goal is. Like in this problem, the goal is to get sine somehow. So generally what you want to do is take the side that's more complicated and try to simplify it. Don't take the simple side and try to complicate it to look like the other side. That's confusing. Always take the side that looks more complicated and reduce it and simplify it down until it gets simpler. Now, sometimes people that do trig identities, they kind of play with both sides at the same time. I think that's going to get confusing if you try that. In a verify problem, I would leave one side alone. Don't touch it. And then just play with the other side till you're done. Okay, so don't worry about that. Okay, so when you see verify, that's what it means. All right, so the first trick I showed you was to change everything to sines and cosines. Well, another trick we can use is to write things with a common denominator. This trick usually comes up when you have fractions and you're trying to add or subtract them, just like this. Only way you can combine those together is if you find a common denominator. And we can do exactly the same thing with trig. Okay, so we'll come back to that in the next problem. So the second trick, rewriting with a common denominator, when I look at that problem right away, I don't even think of that trick. I don't see any fractions. All my denominators here, it's like they're ones. So right now, I don't have that trick. But it might come up in the problem somewhere. All right, let's go back here. What property can you do? We do it with numbers all the time. You have something on the outside of parentheses and then two things added on the inside.
Distributive.
Yeah, you've got distributive. So if you were thinking, well, that kind of looks like a distributive property, it is. Or if you were thinking, maybe I should change everything to sines and cosines, that's also right. You have to do both. So let's distribute this out first. So it's sine times cotangent plus sine times tangent. Now we've got distributive property done. We can change everything to sines and cosines. Sine, it already is sine. Since everything else in this problem is going to become a fraction, I'm going to make sine a fraction too. Cotangent. How do we write cotangent? Yep.
Cosine over sine.
Cosine over sine. Plus sine, it's already sine, so just leave that alone. Times tangent. Sine over cosine. Now, I see a lot of things that are in the top and the bottom that are the same. I see a cosine here and a cosine here. Can I cancel them? No, why? They're not, yeah, it's addition. You can't cancel across an addition or subtraction sign. You can cancel across a multiplication. So is there anything here we can cancel? What can we cancel? Yep.
2 of the time.
Yeah, you can cancel those, that's fine. So now you're left with cosine over 1. That's all that's in the bottom. Plus, now let's multiply out the top. Sine times sine. It's just like doing x times x. Sine squared. If it was sine plus sine, it would be 2 sine. Okay, but sine times sine is sine squared. Okay, so now we have that. Well, we can't change this to sines and cosines. It already is. So that trick's not going to work. We already used it. What could I do with those two fractions now?
Add them.
Yeah, and what do you need if you want to add fractions?
Common denominator.
You need a common denominator. So if you had something like this, and you wanted to find the common denominator, what's the common denominator between 3 and 6?
6.
It's 6. So if you wanted to add these up, does that fraction need to change?
No.
It already had a common denominator. It's fine. Does that fraction need to change? Yes. You need to multiply by 2 and by 2. And now you can add it up and you have a common denominator. All right. So let's look at over here. The common denominator is the product of the two denominators that you already have. So the common denominator here is 1 times cosine, which is how much? It's cosine. Does this fraction need to change to make it have a denominator of cosine? No, it already does. Does that fraction need to change?
Yes.
Yes. What would you multiply top and bottom by?
Cosine.
Cosine. You always multiply top and bottom by the other denominator. That's how it works. So cosine over cosine. So cosine times 1, I got that. What's cosine times cosine? Cosine squared. So now you've used every trick I've shown you. You changed to sines and cosines. You have a common denominator. Now there's something there you have to recognize. It's part of the identities you wrote down when we started. Anybody see anything there? Yep.
Sine squared plus cosine squared equals 1.
Yeah, this is sine. I mean, we wrote it as sine squared plus cosine squared. That's the same thing. Cosine squared plus sine squared. What did you just say that all turns into?
1.
1. So if you forget that sine squared plus cosine squared is 1, you get stuck. Okay, that's where you got to go back and look at your identities. And now 1 over cosine is what? Secant. So we ended up with something very simple, just a single trig function. And we started with something pretty complicated. 3 different trig functions with a distributive property. Okay, and it all simplified to secant. Okay, that one's a little harder than the first two. Definitely a little harder. Probably about the difficulty you would see on a test, with some easy ones too, like the first one. Okay, let's try this one. So verify. This is our first verify. So when you verify, my suggestion was start with the side that looks more complicated. Which side looks more complicated here? The right, yeah. So RHS, right-hand side. We're just going to keep working with the right-hand side, and we know we're done when we simplify the right-hand side to sine. That's the goal. So I'm just going to copy the right-hand side over. Secant, tangent, plus cotangent. Okay. What could I try first? Yeah, you can't do the common denominator trick because you only have one fraction. Common denominator means you have two separate fractions. Well, so the only trick we got is change to sines and cosines. So it's probably going to make it look worse at first, but the hope is that when we start doing some other things, we make it look better. Tangent, sine over cosine, and cotangent, it's cosine over sine. Now there's not really a lot you can do with the top. It's just a fraction, it's all by itself, there's nothing to combine with it, there's nothing to simplify in the top. But let's look at the bottom. What could we do? Well, because that's addition, we can't cancel. If it was multiplication, you could cancel everything out. But with addition, you can't. What's the only thing you can do when it's addition with fractions with different denominators? You've got to get a common denominator. Even if you're not sure how that's going to help you, just try it and maybe you'll see what happens. So the common denominator is the product of the two that you have. What are the two that I have? Cosine, sine. So at the bottom, we've got cosine, sine. What is that fraction missing? So it has the common denominator. It's missing a sign at the bottom. So we're going to multiply top and bottom by the other denominator. What is the fraction on the right missing? It's missing a cosine. So you multiply top and bottom by the other denominator. So now the bottoms are sine, cosine. They're both sine, cosine. What's sine times sine? Sine squared plus cosine times cosine. Cosine squared. Now it looks bad, but there's a lot of that that's about to go away. This whole thing turns into a 1. It's all gone. So now we just have 1 over cosine over 1 over cosine times sine. Now we're back in the situation where we have a fraction divided by a fraction. That's very similar to the first one. What do you do when you have a fraction over a fraction? Multiply by the reciprocal. Again, if you're not even sure what's going to happen, don't just try it. Maybe something cancels out. So what do I do to the top? Do I flip that? No, that stays the same. I flip what? Flip the bottom. The bottom becomes sine cosine over 1. Sine cosine over 1. Now, what can I do there? I can cross out the cosines. I can even cross out the 1s. And what am I left with? I'm just left with sine. So again, and now we can go back up and we know if that's right because they told us what we should have gotten. we were supposed to get sine when we were done, and that's exactly what we got.
So what do we write to say that we just found?
So the work is, all I'm going to look for is that you showed me those steps.
Okay.
I'm going to look and say, okay, they ended up with sine, they were supposed to get sine, how did they do it? And I'll look at your work.
Okay.
Yep. Any questions on that one? Oops, that's the one we did before. That's the one we just did. All right. So the third major trick that's going to come up in these problems, you've got changing to sines and cosines. You've got finding a common denominator. The third trick is the conjugate, multiplying top and bottom by a conjugate. We did that back when we had things like this. When we had to divide complex numbers, the way we did it was to multiply top and bottom by the conjugate. We're not doing complex numbers, but I'm just showing you we've used it before. So the conjugate is when you just change the sign. If it was 3 plus 4i, the conjugate is 3 minus 4i. Okay, we're going to do it with trig, so I wouldn't even worry about writing that down. I would just write this. So you know to use a conjugate when you see something like a trig function plus or minus a number, or a number plus or minus a trig function. Just like that. A number minus a trig function. That hasn't come up in any other problem we've done. Okay, so conjugates come up when you see a problem with fractions, and in part of the fraction, it looks like a number plus or minus a trig function. Now, when you do verify, I said to start with the side that looks more complicated. Is there a side here that looks more complicated? Not really. They both kind of look the same. They both are fractions. They both have a cosine function either in the top or the bottom. They both have a 1 plus something and a 1 minus something. They're almost like mirror images. They're like almost the same thing. So it doesn't matter which side you start with. Each side is exactly the same amount of work. So do we want to start with the left or the right? Left. All right. So left-hand side. Our goal is to leave the right-hand side alone. Don't touch it. Play with the left-hand side until it turns into the right. Okay, so let's copy down the left. Okay, could I try the trick of changing everything to sines and cosines?
No.
Why not? It already is, so that trick's not going to work. That's how you know not to use that one. How about finding a common denominator? No, I only have one fraction. To have common denominators, I got to have two fractions with a plus sign or a minus sign between them. I don't have that. So the only trick left is the conjugate. Now, when we're looking for the conjugate, is the conjugate going to come from the top of this fraction or the bottom? The bottom. It has to come from the thing that's a number plus or minus a trig function. It's 1 minus sine. What's the conjugate of 1 minus sine? 1 plus sine. All right. Now, anytime you have conjugates, the way you want to do it is FOIL them out. That's how you multiply. First, outer, inner, last. Don't do anything else in this step. If you do, it's going to get harder. Because if you look at the top, you might think, wait, I have cosine. Shouldn't I just distribute it out? No. It is a distributive property, but you're not even going to have to worry about it because of what's about to happen in the next step. All right? So that's why when you're kind of new to these and you don't know what's going to happen in the next step because you're just worried about this step, if you see conjugates, multiply them out and don't do anything else in that step. So let's leave the top exactly like it is. And trust me, you'll see very soon why I'm doing that. Okay, let's FOIL it out. 1 times 1 gives me... Good. All right. Pre-calc. All right. So 1 times positive sign, but then look what you're going to have next. 1 times negative sign. What's going to happen there? 1 times positive sign,
Cancel.
1 times negative sign. Anytime you have conjugates, they're always going to cancel. So you really don't need to worry about the outer and the inner. All you have to do is the first and the last. Negative sign times positive sign. Well, what's a negative times a positive? It's a negative. And then sine times sine.
Sine squared.
Sine squared. Now, you might still be looking at that and you're like, I still don't see why we didn't just distribute what's in the top. But look at what's in the bottom. 1 minus sine squared. I mentioned this earlier. 1 minus sine squared is something special. Right, it's cosine squared. Remember when I said... Actually, I have it right here. When you can rearrange these identities, 1 minus sine squared is cosine squared, and I explained that one. That's exactly what just came up in this problem. 1 minus sine squared. So let's change it. Keep the top the same. What did we just say the bottom was? Cosine squared. Now, what do the top and bottom have in common? Cosine, how many? Just 1. You can cancel 1 from the bottom. You can cancel 1 from the top. And look what you're left with. 1 plus sine over cosine. Let's go back up. 1 plus sine over cosine. These kind of problems all work that way every single time. Okay? You happy?
Yeah, I thought we were going to have to do the right-hand side too.
No. If you did the right-hand side, it would have been the same steps. You would have multiplied by 1 minus sine. You would have FOILed it out. You would have gotten a trig identity, just like we did right here, and then something in the top and the bottom would have canceled. It would have been the exact same steps. Yep. That's it. That's a verify. Questions on it? Okay, I make it look easy. Maybe, I don't know if you think it's easy, but usually it looks pretty easy when I'm doing it, but once you do it, sometimes you get a little stuck. So that's why tomorrow we're going to review. This one's pretty much the same. Let's see, this one. Let's do... All right, let's try this one. Okay, what's a little tricky about this one? Well, first you got to figure out which side you want to start with. I would start with the right. To me, that looks more complicated because when I look at the right, I see 4 things. I see a tangent, cotangent, another tangent, and another cotangent. On the left, I only see 3. A tangent, a 1, and a secant. But on the left, they're squared, so maybe you could argue that's more complicated. I don't know. But I'm going to start with the right. Now, usually, I said a lot of times changing everything to sines and cosines is a good move. And you can always do it that way. If you change things to sines and cosines, I promise you can get the answer every time. But it might not be the easiest way. There's an easier way to do this one. With this one, we're going to change everything to tangents. Okay? The reason I'm going to change everything to tangents is because when I look at that left-hand side, I see that it has a tangent in it. When I look at the right-hand side, I already see a couple tangents there. So maybe I can use what's already there to help me to get tangents on the left. But I have cotangents on the right. I don't see any cotangents on the left. So let's get rid of the cotangents.
They cancel out on the right.
No, because it's addition and subtraction. It's kind of like if you had 2 minus 6 over 2 plus 6. You can't just say that the answer is 2 divided by 2. It doesn't work. But if it did, that would be that would have been nice. It would have been phenomenal. All right, so let's try something else. Let's change everything to tangents. I see some cotangents on the right. I don't see cotangents on the left. So let's change this into more tangents. The first one already is tangent. How do you write cotangent in terms of tangent? Yeah, it's just like you type it in on the calculator. 1 over tangent. All right? And now we've got tangent, and it's the same thing except plus. Right. Any questions so far? All right, now let's find a common denominator in the top and in the bottom. So
We can't multiply by a conjugate?
I'm not you. Yes, you could. You could see maybe that would work quicker. I don't think it would. I think it would make it harder. But you could try it. The only reason I'm not thinking conjugate is because I don't see something like this. I don't see like a number plus or minus a trig function. I see a trig function plus or minus another trig function. But if this wasn't here, then maybe I would be thinking conjugates. Tangent plus 1, tangent minus 1. But it's not quite set up that way. So let's look at the top. What's the common denominator of the two denominators that's in the top? It's going to be tangent. So we're going to write the top with a denominator of tangent. What's going to be the common denominator of what's in the bottom? It's also tangent. It's the same. The top and bottom are the same, except one's plus, one's minus. That's the only difference. Does this fraction already have a denominator of tangent? It's fine. Does that fraction have a denominator of tangent? No. No. So what would you have to multiply by? Tangent. And now look what happened. We multiplied top and bottom by tangent. What's tangent times tangent?
Tangent squared.
Tangent squared. Right? That's good. We were supposed to get tangent squared. We were supposed to get a minus 1. That's exactly, we kind of got something like that now. Tangent times tangent. Tangent squared. Tangent times 1. There's your tangent. All right. I know, I keep saying tangent. Now the bottom is the same thing, except what's the only difference between the top and the bottom? The bottom one is a plus. So write the same thing again. I won't say what it is. So we got that. Now, let's look at this for a minute. 2/3 divided by 5/3. If you were going to divide those fractions, you would flip the one in the bottom, multiply by the top, and what would cancel out? The 3's. So the way I look at it, when I see two fractions that are in division, I don't even worry about flipping it. If the denominators are the same, they cancel out automatically. If you want to think of it as multiplying by the reciprocal, fine. But they cancel out. So what cancels out here? The tangents, yeah. You got a tangent in the top and a tangent in the bottom. So both tangents cancel out. Tangents are gone. So look at what you're left with now. In the top, you have tangent squared minus 1. That's exactly what you wanted. So the top is perfect. We don't want to do anything else to that. What's in the bottom right now?
Tangent squared plus 1.
Tangent squared plus 1. Now, what did we want in the bottom? We wanted secant squared. But let's go back and look at tangent squared plus 1.
It equals secant squared.
Right there, tangent squared plus 1 is exactly what you really wanted, and that identity says what? Tangent squared plus 1 is secant squared, and we're done. All right?
Yeah, we're done. What's the homework?
Well, we're done this point. We still got 6 or 7 more to do.
Won't do it.
Alright, so top, leave it the way it was. And what did we say tangent squared plus 1 is? It's secant squared. So you took the right hand side and we changed it into the left hand side. Now you could have started with the left hand side, but I've never tried it that way. In theory it would just be all of this in reverse. I think it's easier to start with the right and change it to the left. How do you know that? It just takes a little practice. A lot of times if I start doing a problem and I find I'm like 6, 7 steps into it and it's getting worse, then I start over and maybe I try the other side. So if you start doing one and you notice you're at like step 6 or 7, you probably did something wrong because none of the problems I give you are more than like 6 or 7 steps. These are all pretty much the same. Alright, so that's the homework on 407. It's 4 through 8, 11 and 12, 21, 22, and then 25 through 27. So tomorrow we'll do a review day. The review is going to focus on everything. So it's going to be a worksheet that's exactly like the test, except different problems, right? So that's what we'll do tomorrow.